Good evening, sir.
Good evening. When I கேக்குதுங்களா?
Yes, sir. Audible, sir.
Is it audible?
Yes, sir. Audible, sir.
Okay. Wonderful. Okay. Sorry, I couldn't make it. Yeah, we'll start. இந்த ஆடியோ போதும்ல? Okay.
Start, sir.
Yes, we can start. Yeah.
The great man Thiruvalluvar says, "Aruvina enba ulavvo, karuviyad kaalam arindu sein." To improve the golden moment of opportunity and catch the good that is in our reach is the great art of life. A very warm good evening, galaxy of intellectuals, invited guests, professors, students, ladies and gentlemen. I am Dr. Anna, Assistant Professor of Vinoth College. It's a matter of immense pride to stand here before all of you this evening. On behalf of PG Department of Computer Science, we are delighted to offer a gracious welcome to all. A Danish philosopher Soren says, the function of prayer is not to influence God, rather to change the nature of the one who prays. I like to call upon Professor R. Cynthia Monica Priya, Assistant Professor of Bishop Weber College, to invoke the God Almighty.
Let's pray. Gracious Heavenly Father, we place this day in your mighty hands. Thank you, Lord, for leading us, guiding us, guarding us all through the 3 days of the training program. Thank you, Lord, for all the blessings you have showered on our department. Thank you, Lord, for all the grace and blessings bestowed on each one of us. We thank for the HOD, sir, the faculty members of our department, our Vice Principal, sir, and all the people who stood behind operating and guiding and leading this training program. Bless each one of them. We place them in your mighty hands. Lead us, guide us, guard us all through this day. In the name of our Lord and Savior Jesus Christ, we offer this. Amen.
Thank you, ma'am. Memories without pictures are like life without felicitation. May I request Dr. R. Jamima Periyadarshini, Assistant Professor of Bishop Weber College, to honor the dignitaries through the welcome and felicitation address.
Good evening to one and all. Respected Dr. Alagappa Moses, sir, the Vice Principal of Aided Section, Bishop Weber College, beloved Head of the Department.
Ma'am,
Yes.
you are not audible, ma'am.
Good evening. Am I audible now?
Ma'am, you are
Yes,
not
ma'am.
audible. Just wait, ma'am.
I have
Yeah, I think
unmuted.
Yeah.
Good evening, one and all.
Good evening.
Respected Dr. Alagappa Moses, sir, the Vice Principal of Aided Section, Bishop Weber College, beloved Head of the Department, today's Chief Guest, Dr. Dalvin Vinoth Kumar, and my dear faculty members.
Ma'am, just a minute, ma'am. Ma'am, just a minute.
Yes.
Ma'am, yes, ma'am.
Yes.
Yes, ma'am.
Okay. Okay, once again, good evening to all. And we are here today through online platform on the valediction of the 3 days short-term professional development training program on IoT application development using Node MCU STTP, conducted by the Department of Computer Science, Shift 2, Bishop Weber College. And at this juncture, I would like to thank our beloved principal, Dr. D. Paldayabaran sir, for encouraging us. And my special thanks to our beloved vice principal sir, Dr. Alagappa Moses. Thank you, sir, for being with us and gracing this occasion. And I sincerely thank our beloved head of the department, Dr. Sober Smiles David sir, for continuously encouraging us to conduct so many webinars and online programs. Thank you, sir. And it's my pleasure to welcome and thank our vice principal sir once again. And I hope you might have enjoyed the 2 day session, and today is going to be a fruitful session. And it's my pleasure to specially thank our chief guest, Dr. Dalvin, who has taken so much effort to give a brief insight on IoT application development using Node MCU. And I think IoT is the recent emerging area, and he has given wide knowledge today. For the past 3 days, he has been sharing his knowledge, and really it was a wonderful session. Thank you, Dalvin, for your valuable session. And we are proud that you are an alumni of our college and our department. And my special thanks to the organizing committee who has taken so much effort to conduct this 3 days program. Special thanks to all the staff members of the Department of Computer Science and all the participants. I welcome and thank all the participants who have been with us for the past 2 days. Thank you.
Thank you so much, ma'am. The fragrance of flowers spread only in the direction of wind, but the goodness of a person spreads in all directions. Ladies and gentlemen, we are delighted to have in our midst Professor A. Alagappa Moses sir, Vice Principal, Aided Section, Bishop College, for adding flower of fragrance to the valedictory ceremony. May I invite our Vice Principal sir to deliver the presidential address. Over to you, sir.
A very good evening to all the delegates and members of the faculty and our beloved guests of honor for this program, those who have joined online. So I welcome you all on behalf of the Bishop Weber College. And it's my pleasure to extend my hearty thanks to the organizing committee, the convener, Dr. Sobers, the organizing secretary, Dr. Gayatri, and the other faculty members, those who are convening and conducting this wonderful program for the past 3 days. So my appreciation to you for organizing a program of this kind, the IoT. And I think you are doing a wonderful job in terms of making the young minds to understand how what is the need of the hour and how best the IoT can play a vital role in the daily walks of life, as well as one of the important disciplines to get its momentum and then take its shape in the right direction. So at this juncture, let me have the privilege of congratulating the entire department and for taking up the initiative. So my appreciation and my greetings to you. And as Dr. Jemima said that, I think you have been organizing many webinars and for the benefit of the students and for even the faculty members. I'm sure that this will be a great help and great insight and will enable the entire department to get equipped with the latest trends in development. I understand Dr. Calvin, or Dr. Dalvin. Okay, so you are the guest of honor. So my greetings to you. And I understand you are from the Christu Jayanti College. And I had the opportunity of visiting your college, I think 3 years back, sometime in 2015. I think one professor, I think Dr. Vanitha, I think so. She invited me for one of the Green Initiatives program. So it was a nice acquaintance with your institution. And being an illustrious alumnus of our college, you have been doing a great job in this Prithvi Jayanti College, and I'm sure that your inputs to our students will be of great help. And I'm sure that the demonstration that we have, I could see from your pamphlet, the humidity monitoring and outdoor temperature, and there are so many other things that is being mentioned here, will definitely give a new insight into the young minds of the Iberians, I can say. So, with these few words, I thank the organizing committee for the opportunity that's provided to me, and I apologize that I couldn't make it to be part of your activity in the college itself. I'm sorry that I couldn't, because of the rain and because of so many other logistics, I couldn't join it on time. So I apologize for the delay. And my congratulations to each and every one of you. I thank you, and I wish this program a great success. So thanks to Dr. Gayatri, Dr. Jamima, and Dr. Sobers, and each and every one of you, those who are part of this wonderful endeavor. So my greetings and congratulations to each and every one of you. Thank you very much.
Thank you, sir.
Sir. Thank you so much for your encouraging and motivational words, sir.
Thank you.
The pessimist complains about the wind, an optimist tries to change it, and a leader adjusts the sails. The sails of this particular event were adjusted by a person who not only shares his knowledge about IoT, but a great motivation to all of us to do such a IoT projects. He is none other than our beloved speaker, Dr. Dalvin. May I invite Dr. Dalvin for sailing to reach the destination for this event. Sir, now the forum is yours.
Respected Vice Principal, respected faculty members, dear participants, a warm greetings. So let me start this third day session. I hope in yesterday's session we have discussed about Arduino, how to code it, right? So with this small summary of yesterday's session, we will start today's session. So before starting the session, whether participants, do you have any doubts regarding yesterday's session? If you have any doubts regarding yesterday's session, we will discuss it, and then we will move on to today's session. Any doubt, dear participants? If you have any doubt, you can raise your hand so that the host, they will unmute you. All right. Okay. So yesterday's session we have discussed about Arduino IDE programming, right? So in Arduino IDE programming, we need to take care of three important things. So that is what type of board, that is what type of hardware that we are going to code, and then which port the hardware is connecting, right? That is the first step that we do while opening this Arduino IDE, and then the coding part, right? So in the coding part, we discussed that there are two essential methods, that is void setup and void loop. These are the two essential methods that where we can code our embedded programming. So once we have the code is ready, so then we can compile the code and then upload into the hardware that we have connected, right? So again, we have discussed the very basic example program, that is blinking a light. So how to blink a light, right? So for blinking a light, first what we need to do, whatever the pin that we are using here, so that we need to initialize it, right? So for blinking a bulb, it is an output pin, so we have initialized it as an output. Again, for blinking or to writing the output in the hardware, we are using the method called digital write. So in the digital write, we need to give the pin name and then the status. So here digital write, LED built-in is the pin name, and then high is the status. High in the sense on, right? Again, the delay function. So how long the light need to on, and then the light need to be switched off. So for that digital, again digital write, the pin name. So the pin name which we need to turn off, and then the status of the light, that is low, right? Again, we have discussed about the serial monitor, how to print a message in the serial monitor. Right? Why we are printing a message in the serial monitor? So while executing, we want to see the output. So whatever the programming that we are doing, we can able to see the output in the hardware only, right? For programming purpose, right? If you want to see some printed lines, right? So we can use this serial monitor for seeing the output, right? Again, we have seen the example of analog read, right? So how an analog sensor can read the values and how it can be printed, right? That is what we have discussed in the analog sensor, right? In the analog sensor, how the connectivity is there, right? So most of the sensor it will be coming with 3 pins, right? So two are power pins and the other one is data pin. So the power pins need to be connected correctly. That is the very first step. So power pins in the sense positive and negative, that is VCC and ground. So the VCC need to be connected to 3V3 or Vin, and then the ground need to be connected to the ground. And then the output should be connected. The output of the sensor should be connected as an input to the hardware, right? So here we are using the analog sensor. So it is connected with the analog input, that is A0 of the hardware, right? Again, we have discussed about the ultrasonic sensor. See, ultrasonic sensor to measure the distance between the sensor and the object, right? If an object is detected, right? So then how long the distance between the object and the sensor, to measure the distance in centimeters. So we have seen the example how the connectivity as like here 2 pins. So why we are connecting 2 data pins here? Since it is an passive sensor, whereas the gas sensor we have seen, that is the analog sensor. So the active sensor, it doesn't need any input, whereas this ultrasonic sensor, it is an active sensor. So we are using this two data. So one is input, that is TX and RX. TX is sending the ultrasonic wave, RX is receiving the reflected ultrasonic wave, right? Okay. Right. So in today's session, so we will be discussing about digital sensor, right? So yesterday we have discussed about analog sensor, right? So today we will discuss about digital sensors, right? And then we will be discussing about controlling a device from the remote area, how to control a device from the remote area, and then how to send the data to the cloud, right? At the last, we will discuss some of the research insights which can be associated with IoT, how your research work, right? How your research work can be implemented using this IoT, right? So that is what we are going to discuss. So at the beginning, we will discuss about the digital sensors, right? So as I said earlier, the sensors are two different types. One is analog sensor and another one is digital sensor. So whatever the data that we are getting, we need to give the data as in digital form to the processor, right? So since we are using the digital sensor, we can connect the sensor directly to the input pin instead connecting to the A to D converter, A to DC, A to D converter in the sense analog to digital converter. Here the analog to digital converter is not needed. So that is the only difference between analog sensor and digital sensor. See, the digital sensor, we are going to connect the data pin to the digital pins, right? So as I said before, here the sensor is having how many pins? 3 pins, right? So two are power pins and the other one is data pins, right? So now the sensor which I have given for this example is Delos temperature sensor, right? So this temperature sensor is one of the cheapest sensor which is available in the market, which is the digital sensor, right? And the advantage of this sensor is this is waterproof sensor, right? So it can be used for your any of the projects. Okay. So now we will see the pin diagram, right? How this pin diagram can be connected to the board, right? So as I said before, the power pins, right? Power pin VCC, right? VCC need to be connected to power pin, right? V in, that is positive. Again, the ground should be connected to the ground, that is negative, right? So now when we are connecting these two wires, the sensor is getting powered, right? So now we have powered the sensor. Right? After giving the power, what do we need to do? We need to connect the data. So here, the data pin, you can connect to any one of the digital pins which is given here. See here in the board, you can able to see in the right hand side D0, D1, D2, D3, like G up to D8. Totally 9 digital pins it will be there. Any one of the digital pin you can connect to this sensor, right? So now I am connecting this digital sensor to D3, right? So remember that whichever the pin you are connecting here in the connection, the same pin you need to give in the coding also, right? Okay. So now we will see the coding part, right? So before moving directly into the coding part, I want to tell you one thing, right? So yesterday, the sensors that we have used, right? The sensors that we have used, what we did for getting the value from the sensor? Simply, we did analog read, and then the pin name, the pin where the sensor is connected, right? So whatever the value given by the sensor, directly we have used. Can you get my point? Right? So whatever the value the sensor is giving, that value can be used directly. Right? Whereas here in this type of sensors, we cannot be able to utilize the value directly. We cannot be able to utilize the value directly. Why? Because so we need to do some manipulations. Manipulations in the sense, so here, as I said before, this sensor is working based on the resistance. So now this is a temperature sensor, Delta temperature sensor. So this sensor is going to give the output, right? So that output need to be converted as an meaningful temperature value, right? So whatever the data this temperature sensor giving, that is not the exact temperature value. We need to do some calculations to convert that as an readable temperature value. You need the temperature value in degrees Celsius, or you need the temperature value in Fahrenheit. Whatever the form you need to do some calculations, right? So here, don't worry about the calculations. Why? Because as I said before, the manufacturer of this sensor, they have already given the library. Right? They have already given the library. What do we need to do? We just need to import the library to our code, and then we need to call the function. Right? So that function will do all the calculations and it will give you the temperature. Can you get my point? So if you are directly getting the sensor value, you need to do the calculations to identify the temperature value, right? So the sensor manufacturer itself, they will be giving the library files, right? So here you can see in the code, I have included the library, that is Delos temperature.h. And then the other library which I have included here is onewire.h. So these are the two libraries. These are the two libraries which is used for converting the value as a temperature sensor value. Okay. This temperature sensor value, which is monitored, which can be monitored through the sensor. Okay. Now we will see how to import this library, right? How to include it. First, if you are using directly this library, if you are including directly this library, it will throw an error. See for example, in your C programming, right? So you will be using math.h, right? You will be using math.h. So that library, right, it will be available in your Turbo C itself while it is installed. Right, while it is installed. Whereas this Adreno software while you are installing, right? So that time those libraries and all it won't be there. Right? Since it is an open source, many different libraries were there. You can take or you can install or you can add that add-on whenever you need it. Right? So that is the thing. So now we will see how to import or how to install this libraries. Right? So now what we need to do, you need to go to the menu, right? So in the menu you can able to see the sketch, right? So in the sketch you can able to see, right? Here, include library. Right, include library. So in the include library, here you can see these are all the available libraries. Right, here you can able to see these are all the available libraries. Right. So now you want to install this library. So in this include library, at the top you can able to see manage libraries. Right. So in the manage libraries, if you click a new window, it will be opening. Right. So in this new window, first what it will download what are all the libraries available in your installed package. Right. So till that we need to wait. So once the downloading process completes, so this downloading is from your device. So what are all the libraries already you have installed, right? So once this downloaded process, that is downloading process completes, right? So here you can be able to search. So here you can be able to search. So in this search button, you need to search the last temperature. So here you can able to see the last temperature library. So here in my case, I have already installed. So it is coming as installed, right? See, for example, if I am clicking this, here you can able to find the install button. You need to click install and then install that library, right? So once you have installed the library, this library will be available in your IDE, right? So once it is installed, you can directly go there, right? Okay. Oh, so now I have installed the library, right? So the remaining things, see here I have created one object, so that is one wire. So that one wire object I am passing here, right? Again, the main part over here is this is that is sensors dot request temperatures. So that is the function. That is the function you need to call for converting the sensor value into temperature value, right? So this function is not universal function for all the temperature sensor calculation. See, this is Delas B18B, right? Delas B18B, that is the model number of the sensor. Other than this, many other temperature sensors are there. See, let's say DHT11. So DHT11 is also a temperature sensor. For calculating the temperature using the DHT11, you no need to use this function, right? So this function is especially the part of Delas B temperature only, right? So the thing what you need to explore here is whatever the temperature sensor you are using, you need to search the concerned library for the temperature sensor. To that library, what is the method to calculate, right? See, once you have identified the temperature sensor, right? So directly you can download the library, right? So once you have downloaded the library, what you can do here in the file, if you click in this file, here you can able to see the examples, right? So damn sure, right? Damn sure, all the libraries will be having the example programs, right? So if you are getting a new sensor, what you can do, you can Google it, the sensor name, and then you can take the sensor name, you can install the library first. So once you have installed the library first, you can come to this examples, and then here you can be able to see the example program for the concerned sensor. See, for example, now the last temperature sensor. See here, you can able to see many example programs using that sensor, right? You just click that example program and then you can upload it and then you can, right? So that is why I am not giving the importance in explaining the programming line by line, because you no need to worry about the programming part, right? So the coding, everything, it will be available in the library. The thing is which library you want to use, where you want to connect, how to do it, right? That is the thing you need to know. right? So you don't need to worry about the coding part, right? So this is a function which is used for calculating. Again, see here, serial.println sensor.get temp c by index 0. So this is the function, that is sensor.get temp by index 0. So that is a function which is used to return the temperature value which is calculated from this. See here, I am calling sensor.request temperature. So that is the first function. Whatever the requested temperature it is returning, it will be available in sensor object. After with the same object, I am calling get temperature C by index 0. So here, why we are using index 0 in the sense? So now if I am using two or more temperature sensor in a single wire, right? So to mention which sensor, here we are using the index. If you are using two sensors, you can call the index by 0 and 1, right? By that you can get the temperature value by the index, right? So now this is all about the getting the temperature value, right? So in the analog, we have just given the analog read alone, right? Analog read alone, and we have get the sensor value, and then we have entered it, right? So now we will see how the code is working, how the programming is working, right? So this is all the coding. So now I am going to connect my board. So in this board connectivity or where we need to connect. So the data pin in this program, the data pin which I have used D3, right? So I need to connect the data pin in the D3 and then the power pins to the power pins, right? So always I suggest, right, whenever you are coding this board or Arduino board, right, you upload the code first, and then connect your sensors, right? And then connect your sensors. Why? Because if you are connecting the sensor before uploading itself, while you are uploading, at the time the sensor will throw some garbage values. That garbage values will be stored in your board. Then there may be a chance of getting your output as an error. So it won't applicable for all the sensors. Few sensors it will do like that. Some misfunctions will happen, right? So before uploading, you need to remove all the sensors, upload the code, and then connect the board, right? So now I am connecting the board. I have uploaded the code, and then now I am going to connect the board. I am giving the power, that is positive to positive, negative to negative, and then the digital pin, that is the data pin to D3, right? So now I have connected the temperature sensor, right? So now we will see the output in the serial monitor. So here you can be able to see the temperature. So the temperature is 23.63. The temperature is 23.63. So now that is the environment temperature. So now what I am doing, I am taking some hot water. I am going to dip the sensor in the hot water, and let us see the difference. Let us see the difference in the environment temperature and the hot water. So now what I am going to do, I am going to dip the sensor in the hot water, right? So instantly if you are dipping, it will take some time to give you the exact temperature, right? So it will take some time. So here the value which I am printing is I have given 2 seconds delay. So even 2 seconds it will print the value, right? So in the 2 seconds, what is the value it is printed, right? So after few seconds, it will give the accurate temperature value of this water, right? Can you able to see the temperature of this hot water? So now the temperature of the hot water is approximately 47 degrees Celsius, right? So now what you can do, so after getting this temperature value, you can give the actuator. So based on the temperature value, if the temperature goes beyond this, turn on the air condition, right? So what you need to do, you need to connect the air condition or fan to the board, and then that pin you need to give as an output pin, and then you need to operate it as an output. Okay. Any doubt in this temperature sensor? right? So how to download a library, right? So most of the sensors nowadays which is available in the market, so which is having these type of libraries, right? So what you can do, you don't need to worry about the calculation. See, for example, gas sensor, right? So this is the gas sensor, right? So it is called as MQ135, right? So this MQ135 sensor can sense CO2, it can sense oxygen, right? It can sense LPG gas, right? So one gas sensor will sense many number of gases. But the thing is, it is having only one data pin, right? Only one data pin. In this one data pin, which gas value it is giving? It is giving CO2. Someone is raising the hand. Do you have any doubt? Any doubt? Dear participants, do you have any doubt? Okay. So it is having only one data pin. In that data pin, which data is coming? Which gas value is coming? Right? So the value which is coming in this data pin, it is not the exact gas value. It is the sensor value. That sensor value need to be calculated as an reasonable gas value. For that calculation, we need to download the library and we need to use the function for calculating the carbon value. We need to use the function for calculating the LPG value. Okay. So now we will see the next program. So that is controlling a device using the remote control. Right? Okay. So now for controlling, see controlling in the sense, see the programs that till now we have seen, right? The programs till now we have seen, we have not involved any communication. We have connected the sensor to the board, right? In the board itself, we have seen the output. Right? We have in the board itself, we have seen the output. So now what we are going to do, I am having two different devices, right? So one is my mobile phone, another one is my hardware, right? So now what I am going to do, I am going to control this hardware using my mobile phone, right? So if two different devices or two or more devices involved in the communication, we need the communication. So what communication? Right? Ultimately, it will be the wireless communication. Right? So what communication we need to use? So in the very first beginning introduction, we have seen many different communication technologies. Right? So like Bluetooth, Wi-Fi, right? So these are the communication technologies, GSM. Okay. So now in this example, we are going to use Wi-Fi communication. Why we are using Wi-Fi communication in the sense, so the hardware which we are chosen, that is the node MCU, by default, it is having the Wi-Fi shield. You don't need to add any other communication shield to it, right? So if you want to use Bluetooth, you need to buy the Bluetooth module separately and then you need to connect. Okay, so now here this board itself having the Wi-Fi communication. So I am going to use Wi-Fi communication, right? Again, as I said before, right? So you no need to worry about the communication part. So everything, the library is there. You just download the library and then you can call the functions, right? So for this Wi-Fi communication, the library which I am going to use is ESP8266. So here the ESP8266 is the processor name. So whatever may be the Wi-Fi, right? The IEEE 802.11 standard, right? So this IEEE 802.11 standard will come in the processor IC named ESP8266. Okay, so that ESP8266 Wi-Fi.h. So that is the library that I am going to use for connecting this Wi-Fi. Right. So here these are the library functions which I have used for Wi-Fi connectivity. Here I have used the variable name called LED and I have assigned the to pin number 2. Right. So now I am using the pin number 2. Again, the most important thing that you need to know here is, see, the other remaining things, it will be available in the example program itself, right? So you no need to worry, you can upload. What is the change you need to do here, right? So that is very, very important. The main change that you need to do here is you need to include the SSID and the password of your own, right? So now what I am going to do, I'm going to connect this board to this mobile, right? So now this mobile I'm going to use as the hotspot, right? So this I am going to use as a Wi-Fi, right? So now what I need to do, I need to give the username and the password, the hotspot of this mobile to this hardware. Okay, so that one you need to give here in the SSID, right? So in my case, for my mobile, I have given the SSID as IoT, right? IoT. SSID is nothing. So whenever you are using the Wi-Fi, if you are scanning for Wi-Fi, right? So some available Wi-Fi's you can able to see, right? That name is coming, no. So that is called as SSID, right? Again, the password for this SSID, right? So I need to give the password. So whatever the user SSID and password I have given for my hotspot, that I need to give, right? So once you have given this, right, so it will be connecting, right? So these are all the declaration part, right? You are declaring some variables, and then you will see the setup part, right? So in the setup part, there are few setups were there, so you no need to worry of this setups, right? So everything, it will be setups and all, it will be available directly in the coding book. That is in the example itself. Once you are downloaded the library, don't worry about this setups and all, right? Again, the thing what you need to do here is, so this is setup part, and then this. So here is the looping part. So here is the code comes, right? So here what I am doing is, see, I want to turn the light in this, turn on and off, right? That is my ultimate objective, right? So now how I am going to do in the sense, see, now what I am going to do, I am going to create two buttons, on button and off button, right? On button and off button. Whenever I am pressing the on button, the light need to on. Whenever I am pressing the off button, the light need to off, right? So that is my objective. So how I am going to do in the sense, see here, I am going to use the index, right? I am going to index, using the index, based on the index I am going to do. See, for on and off, what is the code? Digital write. Digital write, pin name, high or low, right? So now I'm going to check the condition. If the index is this, then turn on the light. If the index is this, turn off the light. Right? That is what I'm going to do. This index, from where I'm going to get? I'm going to get from the HTML code. Right? So that is what I have given here. If request.index of, request.index of is /off. If the request of index is /off, then, right, is equal to -1, then the status of the LED is equal to 0. I'm converting the status into 0. See, digital write LED high, right? Again, if the index is on, then I am turning on the light, right? So here, whatever the index I am passing, here I am giving on and off. /on means turn on, /off means turn off. You can give /1, turn on, /0, turn off, right? So that is the code I have given here, right? So now, how this HTML code, can be embedded to this code? Sir, you said this is an embed C programming, right? So HTML programming, to run the HTML programming, I need a browser. How it can be implemented, right? So this embed C having the provision to use the HTML tags using the conversional methods. There are some libraries which is going to convert your C program, embed C program into HTML program using the tags, right? So that is what we are going to do here. Let us see how. See, now here I have given the example HTML code, right? So what is this HTML coding? Here you can see, let us execute this HTML and see. HTML code. Now I'm going to open that in the browser. I'm going to save the file in the desktop. So the name which I'm going to give for this is HTML code dot txt. Now I have saved the file as HTML. Now I'm going to open it in the browser. And you're able to see this is the output for my HTML code, right? So I have created two buttons. Can you able to see on and off? These are the two buttons I have created. If I am clicking the button on, see here, this is the address tab, right? So here, what the index is going to come. Whenever I am pressing this on button, right? Whenever I am pressing this on button, see here, flash on. This is the index. Can you get my point? So whenever I am pressing on, what it is coming here? Slash on. So whenever I am pressing off, so here what is coming in the index? Slash off. So this index only I am going to get. And that index will be sent to the hardware. So that hardware is going to check if the index is on, then turn on the light. If the index is off, then turn off the light. Right? So this is all about the HTML coding. Right? So now this HTML coding cannot be written directly, right? Cannot be written directly to the Embedded C programming. For that, you no need to worry, right? What you can do, you can write your HTML code, right? Once your HTML code is ready, your design is ready. What you do, you copy all the codes, right? You copy the HTML code from HTML to /HTML. You copy the code, right? So directly go to Google, right? So here you can Google it HTML to Adreno. You can give HTML to Adreno code. So you can able to find n number of online converters, right? So any one of the online converter you can choose. So in that converter, you paste the HTML code and give convert. So it will be giving the embedded code, right? So you need to copy this embedded code and then you need to paste in the Adreno IDE. Here you need to paste in Adreno IDE, right? So now let us see how it will be, right? So this is the HTML code, right? This is HTML code. So if you want to embed this inside the Adreno board, you want to embed the tags. See here, I am using string web, right? I'm using string web here. So using the string web, what I am going to do here is, so here I am using all the HTML tags. Right? Here I am using all the HTML tags. So here you can able to see that on and off coding. So here you can able to see string web plus is equal to HTML. See how the tag I am coded here. Okay, so this is how all the code it should be there. So okay, so this is how you need to give this HTML code. To do this HTML code, see I didn't change any HTML tags here. See, HTML, body, h1, everything is there, right? So what I have did, instead of giving directly the tags, I have added this line to everything. So this is my HTML tag. So I will differentiate using. See, this is the HTML tag, right? So that will be coming in the double quotes, right? It is coming in the double quotes /r/n, right? So web plus is equal to inside the double quotes. Inside the double quotes, you need to give the HTML tag, right? So why I am using web here? So string web. This is the variable I am using. See, instead of web here, I am going to use. So here, wherever web is there, you need to use. So that is the variable user defined. So this variable, wherever I'm using this variable, which is going to indicate that that is the HTML code. It will instruct the compiler that wherever this variable string $, is coming, that is the HTML code, right? So this is all about the HTML code. So let us upload the code and then check, right? So now what I am going to do, I am going to upload. See, I am uploading the HTML code also here. I am uploading the embedded code. See, everything is in one code itself, right? I am uploading to the code, right? So now, once this code is uploaded, how the output it will be, right? So before that, what we need to do, I have used the SSID, IoT, and the password is 28. So what you need to do, you need to turn on the hotspot. So now what I'm going to do, I'm going to turn on the hotspot in my mobile. So which is having the SSID and the password as IoT and 128. So that is the SSID and password which I am having here, right? So you need to turn on the hotspot, and then only the board can be connected to the hotspot. Okay. Let us wait for the code to be uploaded in the hardware. So now the code is uploaded, right? So now the code is uploaded. You can able to see a light is glowing in this board, right? So now what I am going to do, I am going to control this light using my mobile, right? So before that, I need to know the IP address of this board to connect to this board, right? So now, see, now this hardware is connected with this mobile, right? So now this hardware is connected with this mobile. Okay. So this is the hotspot and this is the Wi-Fi, right? So now the connection is established. So now what I need to do, I need to call this board. I need to call this board in the browser. Why? Because it is giving the output in an HTML. So if you want to see the HTML, you need to put that IP address in the browser, right? See, if you are calling this board in an Adreno or in a Android app or iPhone app, what you need to do? You need to give the IP address to that app, right? The app that you are designing. So in this case, what is the application we are using? We are using the HTML page. So to view the HTML page, what you need to do? You need to go to the browser, right? So now what I am going to do is, I am going to go to my browser and I am going to type the IP address. To see that the IP address, right? So here in the coding itself, it is given to print the IP address of this board in the serial monitor. right? So now I am pressing reset. So once I have pressed the reset, then automatically it will be connected, right? So here you can able to see the IP address, Wi-Fi connected, server started, and the IP address is 192.168.43.12. So that is the IP address of this hardware. Okay, right. So now what I am going to do, I am going to give that IP address in my browser, right? Wait a second, I will connect. Second, I will connect through my mobile so that I will share my screen so that you can able to see. Sir, can you able to make my mobile as an co-host so that I can share my screen? Ma'am? Ma'am, can you please hear me, ma'am? Gayatri, ma'am? Gayatri, ma'am, are you there? Can you able to see my screen here, right, in the mobile, right? So whatever the HTML code that we have did, it will be coming here, right? So what I am going to do is, now I am going to use the button, right? So now the light is on. I am going to press the button in my mobile. So I am pressing the button. See, the light is turned off now, right? The light is turned off. Okay. Here in the address bar, you can able to see in the address bar /off it is coming, right? So now again I am going to turn on the light, right? I'm going to turn on the light. So if I'm pressing the button turn on, the light is on. So using the Wi-Fi control, I am controlling this device, right? I'm using the Wi-Fi and controlling this device. Okay. So on and off. Right? So you can design, right? You can design as like your wish. See why we are using the HTML code, so that the HTML code will be viewed in the browser. Right? This HTML code will be viewed in the browser. See, whatever the HTML page which we have given here, so that will be visible in the device which is connected. Right? So now, listen. This is the hotspot. This mobile is the hotspot. Again, this is the slave. So this is connected to this hotspot, right? So now I am connecting this board directly to this mobile, right? Let us take the scenario like this. Let us take the scenario like this. So now what I am going to do, I am, instead of connecting to this mobile, I am connecting to this board to the Wi-Fi router which is configured in my home, right? So what you need to do, the SSID and password of your home Wi-Fi, you need to give in the coding, so that this hardware will be connected to the Wi-Fi. Again, what you can do, you can connect this mobile to your home router. So now this mobile is connected to your home router, this hardware is connected to your home router. So now these all are coming in one network. So you can be able to access this hardware using this mobile, even though it is connected to that Wi-Fi, right? So this connectivity only I have quoted as device to gateway connectivity. Can you get my point? On that day, we have seen the smart device connectivity, right? So now this example, device to device communication, device to device communication, right? So the the other way, what you can do, you can connect this to your home router. So what are all the device, which are all the device connected to your home router that can able to control this hardware, right? In your home, you 5 members were there. Everyone having your own mobile. The light is common. So all the 5, you can access the light using the IP. Right, students, any doubt in this? Any doubt in this? Oh, we will go to the next part. That is, right. So the next part is connecting to the ThinkSpeak. Right, connecting to the ThinkSpeak. See, ThinkSpeak is nothing but it is a storage medium, so which can be stored in the cloud, right? So whatever the sensor data that you are getting in the hardware, that we are getting in hardware, here this limitation of computational power, right? You can't be able to store more data, right? So what you can do, you can save your data in the cloud, right? So for that cloud medium, what you can do, you can store your data. See, now let us take your real-time example. If you want to store your resume in the cloud, what you will do? Just you will log in to your Gmail, Google account. You will open the drive. To the drive, you will be storing your resume, right? So now your resume copy will be available in the cloud. So for that, you need some provider, right, to store your data, because you are not having your own cloud. If you are having your own cloud setup, you can configure your data in your own cloud, right? So the companies like Cisco, Texas, they are having their own cloud for their own IoT devices, right? So now, if you want to practice or if you want to collect the data for your research, right? So you no need to spend. For this purpose, there are many different providers giving you up to 50 GB of your sensor data can be configured in the cloud, right? So one such provider is ThinkSpeak, right? ThinkSpeak is one of the provider. It will provide you the storage, cloud storage, and then the analytical tools for your IoT sensors. This ThinkSpeak belongs to the community of MATLAB, right? So MATLAB comes under MathWorks. So MathWorks is the community which owns this ThinkSpeak also. So what you need to do is just log in to the ThinkSpeak website, right? So just log into the ThinkSpeak website, and then you need to create an account. So for creating a ThinkSpeak account, all you need is a Google account. If you are having a Google account, right? So you can able to create a ThinkSpeak account. Right? So here what you need to do. So here I am having my own account. So what I am going to do, I am going to log in. Right? In your case, so in the very first day itself, I have instructed you to create an account in ThinkSpeak. If you have created, you can log into your ThinkSpeak. If you not created, no issues. See here in the ThinkSpeak.com. Right? If you go to ThinkSpeak.com, ThinkSpeak.com, you can able to see this page. Here you can create something. So now I am going to log into my account. So now this is my account. So in this account, I am having many channels, right? So here, see, imagine for one project, for one project, you will be having 10 sensors. For one project, you will be having 10 sensors. So now what you can do, you can create a separate channel. You can create a separate channel for one project. So in that project, you will be having temperature sensor, you will be having a humidity sensor, you will be having a light sensor, whatever may be the sensor, you can upload the data in one single channel, right? So likewise, you can create a channel. See here, I have created a channel for Bishop Weaver demo data. So that is the channel which I have created. If you click this channel, here you can be able to see the data field, right? So here up to 8 data field you can create, right? 8 data fields you can create. So how to create this? So whenever you are creating, you won't having the channel. You won't be having the channel. So what you need to do, you need to click this new channel, right? So I have already created. So my channel is visible here. What you need to do, you need to create the new channel. Click the new channel. So once you click here, right, the new channel creation option, it will be coming for you. So in my case, I have created ample amount of channels, right? So once you click this new channel button, so it will be asking you the channel name, how many fields, everything. If you are configuring and viewing, right? So then the channel will be created. So once the channel will be created, it will be looking like this, right? So you need to open this channel. So once you have opened this, here you can able to see private view, public view. So you can configure your channel as a private view or public view. Public view means anyone who is having account in ThinkSpeak can able to see your channel, right? Private means you alone can able to see, right? So now you have created a channel. Right? So now, see, I am having 5 channels, right, in my own login. So now you need to instruct the hardware to send the data to the ThinkSpeak. Again, inside the ThinkSpeak, my account, the data need to be synchronized in my own channel. I am having 5 channels. In that 5 channel, which channel data need to be synchronized? Right? To authenticate this or to identify this, here we are using API keys, right? So this is one of the important things you need to do the ThinkSpeak coding, right? So what you need to do, you need to use the API key. Sir, where I can get the API key? So here you can able to see in the menu, public view, private view, channel settings, sharing, API keys. If you click this API keys, right, here you can able to get the API key, write API and read API. Again the confusion comes, whether I need to use the read API or write API. So the read API or write API, based on your need, you need to use the API. See, for example, in this scenario, what we are discussing now, what we are going to do, we are going to send the temperature data to the ThinkSpeak. You are going to send the temperature data to the ThinkSpeak. So now what you are going to do, you are going to write some data to the ThinkSpeak. What you are going to do, you are going to write some data to the ThinkSpeak, right? Again, if you want to control the fan based on the temperature, it's based on the temperature. Okay, see, let's say, imagine like this, you are in the office, right? So once you are started from your office, right, once you are started from your office, you will go to your home. So in your home, the hot water need to be ready when you are reaching your home, right? So now what you will do, your location of your mobile, right, your location of your mobile and the heater, water heater in your home will be configured to the ThinkSpeak, right? So now your mobile will send the location to ThinkSpeak. Your location will be there. So your water heater, what it will do, it will get the location from the ThinkSpeak and then it will turn on the geyser based on your location. If you are reaching near to your home, then your geyser will turn on. So in the second scenario, in this project, you are reading the value from the ThinkSpeak, right? So if you are going to write the value in the ThinkSpeak, you need to use write API. If you are going to read the value from the ThinkSpeak, you need to use the read API. Again, students, here you are not supposed to confuse. See, reading and writing in the perspective of ThinkSpeak. Okay, so ThinkSpeak, you are going to write in the ThinkSpeak. See, ThinkSpeak is reading the value from the sensor. Sensor is writing the value to the ThinkSpeak. Both are same, but in the perspective of ThinkSpeak, it will be read. In the perspective of your hardware, it will be write. Right? The same thing in the sensor. See, while we are giving the sensor, it is an output pin. Right? In the board perspective, we have thinking. Here, in the ThinkSpeak also, we are thinking in the hardware board perspective. The board is going to write the value. Then ThinkSpeak is not going to read the value. Board is going to write the value in the ThinkSpeak. So what you need to do, you need to copy this write API, and then you need to go to the code, right? In the API, you need to just paste it, right? So here you can see, so these are the additional lines. These are the additional lines for doing this ThinkSpeak coding. So whatever the code that you have used for remote control, that is remote control in the sense Wi-Fi connectivity, the same code you need to use. These are the additional code you need to use for ThinkSpeak. Whatever the code which I have used for Wi-Fi control, right? The same you need to use. Why? For ThinkSpeak, you need the internet connectivity, right? For ThinkSpeak, you need the internet connectivity so that it is connected to the internet. Okay, right? So here, once it is connected, right, the API key, right? This is the API key. You need to give the API key. This API key which I have showing here, that is belongs to my channel. And then here you can see string post string, right? So see here, I am using post string as a variable, as like used for the HTML, right? So post string ampersand field file. So what is the field name you want? You can give. See, I have 8 field in my channel. So field 1 will be configured as field 1, field 2, field 3, whatever may be the field. In this field 5, what data I need to upload? String T, that is the value I need to upload, and field 6, string H, that is the value I need to upload. See here, instead of string T and H, these are the two variables. In these two variables, what you can do, you can store the sensor value. For example, in the T variable, you can store the temperature sensor value. In the H variable, you can store the humidity value, right? So whatever the value stored in this variable, that will be posted in the ThinkSpeak. Okay, so how the data will be posted, here you can see. So the data will be posted like this. See here, I have used the channel 5 and channel 6. Here you can able to see the data posted, right? So it will show the label, what is the channel name, what the value is posted, at what time the value is posted, everything it will be available, the data. See, once you can code this board, and then you can throw the sensor, right? By powering through the battery, you can throw the sensor. It will continuously, it will send the data to the ThinkSpeak. Only one thing you need, it needs the data, right? So now if you are connecting to your mobile, you need to turn on the mobile data. Even though the connection is Wi-Fi, right? It is a LAN connection. It needs the Wi-Fi connectivity. Okay. All right. So now you have full-fledged, that is from your sensor data is directly connected, right? It is directly connected to the cloud storage as of now, right? So you can explore your project, or you design your project in way, right? So now I will come to the research scholars. So those who are doing research, right? So if you are a PG or if you are a UG student, what you can do, you can print directly, right? You can do the project and then you can show the project. That's enough. Whereas in the perspective of research, if you see, you cannot be able to do the project and simply show it as your research work. What you can, how you can use this IoT for your research. See, if you are working in a data analytics, right? So if you are working in IoT data analytics, what you need to do, you need to collect the IoT data, right? You need to collect the IoT data and then you need to analyze that, right? For collecting, you can use this thing speed, right? For collecting, you can use the thing speed. So now, how I can download the data, right? So here you can see data import and export. So if you click this data import and export, right? So what it will do? It will download. You can able to download. If you click download, so the data which is uploaded in this channel, which will be freely available as a CSV file. It will be available as a CSV file. What you can do using this CSV file, you can upload into any one of the analytic tools and then you can analyze your data, right? So let's say BigML. So BigML is one of the analytics tools. What you can do, you can feed this CSV file, you can feed the CSV file to this BigML analytics tool and then you can explore, right? So how to do this? So you can click the source and then you can upload the data set, right? So here you can, in the right hand side, you can see add data set. If you click add data set, so it will ask from where you need to add. You need to add from the internet source or you need to add from your local computer, wherever. So in my case, I'm going to add from your local service. See, what is the file I have downloaded? feeds.csv, right? So now I need to choose that data file. See here, this is the CSV file. I'm choosing the CSV file and opening the CSV file, right? So now my data set, see here, feeds.csv is available here. You can analyze it. So whatever the analysis you want to, here you can predefined it will be giving the supervised and unsupervised mode of analysis. It will give the clustering tools, it will give the association tool, it will give the classification tools, it will give logical regression, right? Linear regression, whatever you want to do in that data, you can do. Here, there are some prediction models also. You can do the classification regression prediction model. You can give the cluster analysis prediction model. Whatever the operation you want to do in that data, you can do. And then you can show as your research work, right? Someone had raised their hand. May I know who's that? You want to talk something? You can unmute and then you can talk. Jabas Samuel.
Sir, yes, sir. I wanted to ask few doubts, sir. Sir, your browser is not visible, first of all. I am a research scholar, sir. So I want to know about ThinkSpeak much more, sir. So I want to see the browser which you are
Now my
on.
browser is not visible to you?
Yes, sir. Only the prepeat is visible for me.
Jabas, can you able to see my browser now?
Now I can able to see, sir. Yeah.
Okay.
Thank you.
Okay. So what you need to do, so this is the page. I will sign off and then do. So here, this is the page. Here, what you can do, you can click the sign in and then you can create the new login and then you can create it. See here, I am already having, so I am logged in here. Okay. So this is the page for my ThinkSpeak login, right? So I have already created these many channels, right? So in your case, once you have created new, here the new channel will come. If you click the new channel, you can able to create the new channel, right? So once you click, it will ask for the channel name and then it will ask for how many feeds you want to do. You can configure your channel and then you can create it. Once you have created, it will come like this. So now I have created the Bishop Weber demo. So in this demo, I have created. So once you have opened that, the window will looks like this, right? So these are the fields where your data going to be stored, right? So I have created 6 fields, right? So if you want, you can create additionally, add visualization. What type of visualization you want, you can add. Here you can able to see the another visualization tool will be coming. Whatever you want, you can add the visualization. After this, what you need to do for uploading the data, here you need to click the API key. In this API key, as I said, write API and read API. You just copy this write API and then paste it in the code. Okay. So here in the code, you need to paste, right? Again, for downloading the data, you need to click data, import or export. Here you can see export. If you click download, that data will be downloaded as a CSV file, right? So once this CSV file is downloaded, so here this is one of the open source tool. So it is not an open source, it is a commercial tool, but it is giving free options for analyzing your data, right? Certain extent it will be giving free. For research scholar, it will be okay. For industry purpose, you need to get the license. For research purpose, you can use this tool, that is BigML tool. You can feed your data here and then you can do whatever the analysis. You can want to do cluster or classification, whatever you want, you can do. If you want to prediction, it will do the prediction and then it will give the model itself. That model you can directly choose which model is appropriate for you. That model you can use for your research, right? Whatever the research work you are doing, so you can carry out that research to your work. So this is how this IoT can help in the research, right? So this part, that is, if you are analytics, you can collect the data. For collecting the data, you can use IoT, right? So if you are doing your research in networking, right, how you can use this IoT for your networking IoT research, right? So for networking, what the basically we can't able to buy the routers, right? We can't able to buy the routers and then we can simulate. So for that, for networking researchers, what they will do, they will go for simulators. See, for example, you are developing a routing protocol, right? For seeing the load of the routing protocol, 100 computers need to access the router. 1,000 computers need to access the router, right? So now what you need to do, you need to access through 100 computers. You need to access through 1,000 computers. It is not possible for you to buy 100 computers or 1,000 computers and see lively. For that, what the networking people, what they will do, they will use the simulators called network simulators. So the network simulators, what you can do, directly you can create the computers, routers, and then you can access and see in the software way. Whereas in IoT, what you can do, this hardware comes under 250 to 300 rupees, right? So what you can do, you can buy this hardware, you can upload your routing algorithm, in that hardware. Using the hardware itself, you can able to see the performance of your algorithm, right? Again, the another one major advantage using this IoT hardware is, see, whatever the work that you are doing, before and all, in India, getting the patent or copyright for a computer science professional, it is a tedious task, because the law of the constitution law of our Indian government, you cannot be able to get a patent for a computer software unless until it is installed in a hardware, right? So nowadays, using this IoT, whatever your research work, you can upload, you can code it to the IoT device, and then you can apply for a patent as a device. Okay, so whatever the language, if your research work can be done in a embedded C, you can code it in this hardware. If your research work can be coded in a Python or Ruby, you can go for Raspberry Pi boards. Or else, if you want to do some complications in the sense, if you are working in a routing protocols like Cisco routing protocol, other routing protocols, you can buy the hardware of Cisco itself, right? If there is a blog called Cisco blog, where they will be giving the hardware for researchers for research purpose. They will be giving their own hardware, they will be giving their own softwares for you people to do research, right? So likewise, also you can access ARM hardware, you can access Texas Instrument hardware, you can access Cisco hardware, you can access, right? So whatever may be the hardware, this is the base, right? So like this, you need to connect your board and then you need to access the coding, right? So with this, I stop here. So if you people have any doubt, you can ask. Anyone having any doubt?
Sir, I have one more doubt, sir.
Yes, Jabbar, sir.
Sir, the cloud you said, like, sir, ThinkSpeak, is it free only for institutional ID, or I can access through my personal ID?
Yeah, Jabbar, you can use your personal Gmail ID. You can use, but for one Gmail ID, you can able to create only 4 channels. right?
Four
So
channel.
other only 4 channel, that is the limitations. It is there. So other than this ThinkSpeak, there are many other things. Board is there, Bolt IoT is there. So many different platforms are there. Or else, if you are having your own domain name, see for example, if you people are doing research in Bishop Weber, so Bishop Weber is having their own domain name, right? So to that domain, you can create your own API. In that storage, you can store. Can you able to get my point? So you no need
Yes,
to worry
sir.
about this free accounts also. You can create your own API. You can able to create your own API using that. Or else if you want to store your data in your own system itself, what you can do, you can configure your Raspberry Pi as a server. In the Raspberry Pi, what you can do, you can connect 1 TB data, 1 TB hard disk, right? So your device, what it will going to, instead of connecting to cloud ThinkSpeak, it is going to connect it to the cloud Raspberry Pi. This Raspberry Pi is going to give the storage medium. In the Raspberry Pi itself, you can store whatever the way you want. You can store the rest.
Okay, sir. We have IoT lab in our department. We used cloud for RPI
Okay.
as a cloud interface, sir. Sir, and another doubt, can you show me the API key that you said in the last program, ThinkSpeak, API key in the browser, sir? Because
API
I
key in the
couldn't
browser.
able to see earlier.
Yeah. So you see here, this is my channel. Here you can able
Yeah,
to see write
read,
API
right.
and read API. Okay.
Read it, yeah.
So this is the right API. I need to copy and I need to paste in the code. So this is
Okay.
the pattern of code. So here I need to paste the same. So it
Yeah,
is
thank you, sir.
always recommended to copy paste because while we are typing, there should be some mismatch due to characters, right? So always I recommend you to copy paste it. Any other things to be discussed?
No, sir, thank you.
Okay. Okay. Okay, thank you, ma'am. Thank you, dear participants. So, if you people have any doubt regarding this session or regarding your research, you can contact me, right, at any time. So, regarding your research, I am ready to help you out. Through your conference coordinators also, you can contact. Thank you. Thank you, ma'am.
Thank you very much, Dr. Dalvin, sir, for sharing your deep knowledge about IoT with us. Your words were full of enthusiasm and valuable knowledge. Thank you so much, sir. Gratitude is the fairest blossom which springs from the soul. As we come to the close of our valedictory ceremony, I invite Dr. B. Gayatri, Assistant Professor of Bishop College, to propose the vote of thanks.
Thanks to Almighty, I thank our institution for the generous support. I thank our principal sir for his encouragement words. I thank our vice principal sir, Aiden, for his support. I thank our HOD sir for the valuable ideas given by him. I extend a really hearty thanks to our resource person, Dr. Dalvin Vinoth Kumar sir, who spared his valuable time from his busiest schedule to grace this occasion. I thank you, sir. Your thoughts have enlightened our minds and have shown us a new path. I thank our IT support team. I thank all the faculties who made this training a grand success. I thank to all the participants for being with us in all the 3 days with us. I thank you one and all gathered here. I thank you all.
Thank you so much, ma'am. Thank you so much, dear participants. Have a blessed and fun-filled evening. Thank you so much.
Thank you all.
Dear participants, kindly fill the feedback form. It is in chat box. You will be get the certificates in a week.